Hey, have you ever seen an ambulance cruising without sirens or lights? That's NEATS. The Non-Emergency Ambulance Transfer Service helps patients with mobility issues or mental needs get from home to hospitals. But clunky scheduling and routing are slowing it down, and our project aims to use data-driven method to solve this problem and improve the hospital operational efficiency and satisfaction. United Christian Hospital is a Christian-founded district general hospital serving Eastern Kowloon. According to statistics, about 500,000 patients use NEATS each year, and the elderly account for about 19.45% of them, and this figure is increasing every year. In addition, the ambulance may face some traffic jams, traffic accidents, and some areas without elevator services. These problems will affect the service quality of NEATS, and on average each order will be delayed by about 15 to 20 minutes. In addition, the hospital's current patient grouping and route planning are still manually planned and rely on driving experience to make decisions, which cannot effectively optimize the hospital's resources, resulting in a decline in service quality. To solve the above problem, we use the random forest algorithm and machine learning to solve this problem. We predict the hospital's order demand based on different order characteristics, such as patient type, date, and order type. In addition, in order to solve this vehicle routing problem, we will plan the most reasonable route based on the different characteristics of the order route, such as pickup time, destination, and available ambulance. Based on the historical data provided by the hospital, we successfully used the model to predict the patient's order volume. For example, the accuracy was as high as 91% during peak hours. In terms of route planning, we successfully used the route planning provided by the model to reduce the transportation time by about 10 minutes. And the new route planning also reduced the demand for ambulances by about 20%, which helped the hospital's operational planning. Finally, we made smart decisions through data-driven approaches, reduced patients' waiting time, and improved patient satisfaction. In addition, the hospital was able to use more ambulances to serve more patients, effectively improving the hospital's efficiency.